Here we need to determine moment of inertia of this triangular surface with respect to an axis which is passing through one of its base. So let us first draw that axis, so x-axis and this area. For determining this moment of inertia, we require to take one small area. Let us assume that small area which is at a distance of y with thickness dy. So length of this small area is L and thickness is dy. According to equation of moment of inertia with respect to an axis, x-axis is equal to distance of this small area square. So distance is y, so y square into this small area. You have to integrate. In this way you will get moment of inertia of this triangular area with respect to x-axis. So here dA, this small area, is equal to L into dy. Now remember this L is not a constant value. Its value is varying continuously. When value of y is small, if you take y somewhere here, then L will be more, and if y is more, then value of L will be small. So L is depending, value of L depends on value of y. So we have to determine value of L in terms of y. That we can determine using these two similar triangles. This is one smaller triangle and this one is a larger triangle. These two triangles are similar. So according to that, length of the base of this smaller triangle L, base of this smaller triangle L divided by base of larger triangle, that is B, L divided by B, is equal to height of this smaller triangle. Now height of this smaller triangle is this one, and this height is equal to total height H minus this distance is y. So H minus y, total H minus y is equal to H minus y divided by height of the larger triangle is given H. So from this equation you can obtain value of L in terms of y. Here only variable is y, B and H are constant. Now put this value of L here in this equation and determine Ixx. So put dA equal to, put this value of L here in dA and then replace this dA with this, and now integrate. When you integrate, that integration is very simple integration. After integration you will get these two values, two separate, and finally you will obtain value of moment of inertia as bh cube by 12. So moment of inertia of with triangle, of any triangle, is with respect to its base is equal to bh cube divided by 12, where b is the base of the triangle through which axis is passing and h is the height of the triangle. It's another example. In this example we have to determine moment of inertia of this shaded area. Again the same way, moment of inertia, definition of moment of inertia is integration of y square dA, where y is the distance of small area from given axis. That means we are determining moment of inertia of this shaded area with respect to x-axis. So we have taken a small strip which is parallel to x-axis, its distance is y and thickness is dy. So distance is y, so y square into dA. Now you have to determine this dA, area of this small rectangle. Again same way you can determine area, dA is equal to L into dy. Now L is length of this this smaller strip, that you can determine by by subtracting x coordinate at this point from x coordinate at this point. We know that x coordinate at this point is x square. From this equation you can obtain x coordinate at this point. From so subtract this value. This is x value. Here x value is 0. So you will get value of L is equal to root over a square y divided by b. So x coordinate at this point is root over a square y upon b minus x coordinate at this point is 0. So I have removed this 0. Now put this value of L here in dA, and then replace dA with this, in this equation, and just integrate. Now here a square and b, these a and b are constants, you can take them out, and after taking them out you can integrate y raised to 5 by 2, and you will get finally Ixx. That means moment of inertia of this shaded area with respect to this given axis is equal to ab cube divided by 3. In similar way you can determine moment of inertia of this shaded area with respect to y-axis. For equation will change, Iyy is equal to integration of x square dx, x square dA. Now you have to determine length of the small area, this dA. This small area can be obtained by subtracting y coordinate at this point from y coordinate at this point. So at this point y coordinate is b, so b minus here y coordinate is bx square upon a square. So length of this strip, this small strip, will become b minus bx square upon a square, and thickness is dx, so multiply that. So in that way you will get dA, and then replace dA here and then integrate. Now here limit of integration will change from here a value of x at value of x at 0 to value of x, maximum value of x is a. So 0 way you can determine moment of inertia with respect to y axis. That is for your homework. Thank you for watching this video.